Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 20. Determine the moment of inertia of the shaded area about the x-axis, b, y-axis. So here's the given figure. And for our solution, let's select vertical strip. And take note that there are two identical areas above and below the x-axis. The height of the strip is y, the thickness is dx, and the distance of the strip from the y-axis is x as shown. So differential ix is 2 times 1/3 y cubed dx. Because we have a rectangular strip and its differential moment of inertia with respect to the base is 1/3 height cubed times the base, which is dx, then times 2. So differential ix is 2/3 y cubed dx. Then this is the equation of the upper curve. So when y is b, x is 0. So b equals c, quantity 1 minus k, 0 to the 1/2. So that means b equals c. Then when x is a, y is 0. So 0 equals c, which is b, quantity 1 minus k, x, which is a, then raised to 1/2. So that means k is 1 over a to the 1/2, or 1 over square root of a. Then substitute here, y equals b, quantities 1 minus 1 over a to the 1/2, x to the 1/2. Then into this equation, differential ix is 2/3 of b cube, quantity 1 minus x to the 1/2 over a to the 1/2, quantity cube, times dx. So let's expand this binomial. Cube of 1 is 1. 3 times 1 times 3 times the square of 1 is 3 times the second term times negative x to the 1/2 over a to the 1/2. So minus 3x to the 1/2 over a to the 1/2 plus 3 times 1 times the square of the second, so plus 3 times x over a, then cube of the second, minus x to the 3/2 over a to the 3/2. So ix equals 2/3 b cubed, integral 0 to a of 1 minus 3 over a to the 1/2 x to the 1/2 plus 3x over a, then minus x to the 3/2 over a to the 3/2 dx. Limits is 0 to a because the variable of integration is x. So integrating, ix is 2b cubed over 3, quantity x, 2 over a to the 1/2 x to the 3/2 plus 3x squared over 2a minus 2/5 x to the 5/2 over a to the 3/2, where 2/5 is reciprocal of 5/2 because integral of x to the 5/2 x to the 3/2 is x to the 5/2 over 5/2. So that's why you have 2/5 here. So I hope that you understood the answers, the integrals. These are just power formula, and that's the topic in integral calculus. This is already statics. You're through with integral calculus from 0 to a. So simplifying, ix equals 2b cubed over 3, quantity a, minus 2a plus 3/2 a minus 2/5 a. Then lower limit, everything has x, so 0. So simplifying and combining, ix is equal to 1 over 15 ab cubed. Then for moment of inertia with respect to the y-axis, 2 times differential Iy is 2 times x squared y dx, or distance squared differential area. Differential area is y dx. Y is equal to this. So Iy is 2 integral 0 to a of x squared, then b quantity 1 minus x to the 1 half over a to the 1 half dx. So Iy is 2b, then integral of x squared times 1 is x squared, x cubed over 3, then minus integral of x to the 5 halves is 2 over 7 x to the 7 halves, then divided by a to the 1 half. So Iy is 2b quantity x cubed over 3 minus 2 over 7 x to the 7 halves over a to the 1 half. From 0 to a, so we have a cubed over 3 minus 2 over 7, a cubed lower limit 0. Substitute the lower limits, so 0. So 2 over 21, a cubed b. So that's it for this problem. Level 21, determine the moment of inertia of the shaded area about the x-axis when b, y-axis. So here is the given figure. Again, we have an area which is symmetric with respect to the y-axis. So we consider vertical strip as shown. The height is y, the thickness is dx, and therefore the variable of integration is x. So limits would be from 0 to 4 inches. And the distance of the strip from the y-axis is x. So differential Ix is 2 times 1/3 height cube y cube dx. So differential Ix is 2 times 1/3 y cube dx from our elemental strip, moment of inertia of a rectangular strip with respect to the x-axis. Our base is 1/3 y cube dx, then multiply by 2 because we have two identical areas. So y is already given, so substitute differential Ix is 2/3, then y cube dx. So Ix is 2/3 integral of quantity 2 cosine of quantity pi x over 8 quantity cube dx. So 2 cube is 8 times 2, 16 over 3. And let us denote u as pi x over 8. So differential u is pi 8 dx, and for the limits when x is 0, pi times 0 over 8 is 0, so this is still 0. When x is 4, pi times 4 over 8 is pi over 2. So x is 0, u is 0, x is 4, u is pi over 2. So this is now in the form Ix equals 16 over 3, then integral times the differential, which is pi over 8 dx. We have pi over 8 dx here, so we multiply it by the reciprocal of pi over 8, which is 8 over pi. And this is now in the form cosine of u, or cosine cube of u, then du, where du is pi over 8 dx, and the reciprocal of pi over 8 is this one, 8 over pi. So this is by Wallay formula. Sine does not exist, so therefore by rule it is replaced by 1. Then cosine cube, so therefore minus 1. 3 minus 1 is 2, so stop at 2. Alpha is 1 because this is add, then divided by sum of powers of sine and cosine, which is 3 decreased by 2, so 3, we stop at 1. So this is 16 times 8 over 3 pi, or that's 128 over 3 pi. Then for sine, we replace it by 1. For cosine, the power is 3 minus 1, so 2. We stop at 2. Alpha is 1 because this is add. And the denominator would be the sum of powers of sine and cosine. So it is just 3 decreased by 2. So next is 1. Then we stop at 1. So simplifying that, that's 256 over 9 pi, or that's 9.054 inches to the fourth. Then for differential IY, it is distance square differential area, where differential area is y dx, then times 2. So differential IY is 2 times x squared times y dx. So y is already given. So differential IY is 2 times x squared and 2 cosine of quantity pi x over 8 dx. So simplifying, we have 4, IY is 4, integral from 0 to 4 of x squared, cosine of quantity pi x over 8 dx. So without defeating the purpose of this topic, you may use your high-tech calculator to evaluate this, because this is, after all, an application of definite integral, which up to this present, you are expected to evaluate that because you are through with integral calculus. So it will defeat the purpose of this topic. This is statics, which is ahead of higher than integral calculus. But for uh, reviewing integral calculus, so I will continue, although it will lengthen our solution. You can use your high-tech calculator to evaluate this actually, but set the mode of your calculator to radian mode. So let me just continue. This is integration by parts, so let I denote u sub 1 as x squared. Then the differential of u1, differential u1 is 2x dx. Then dv is this cosine of dv1 is cosine pi x over 8 dx. And the integral of this is 8 over pi sine of pi x over 8, where 8 over pi is the reciprocal of this. So if you still cannot follow, then you should review back integral calculus. That's not the main topic here because this is statics. So it means that if you cannot follow the solution, if you're still confused with this solution here, you need to go back to integral calculus, or you're not yet prepared to moment of inertia involving these functions. So let me continue. So Iy is 4 times u1 v1, this one, from 0 to 4, minus integral of v1 du1. So Iy is 4 times quantity u1 v1, so 8 over pi x squared sine of pi x over 8 from 0 to 4, minus the integral of this product, which is 2x times 8 over pi, so that's 16 over pi. Then integral 0 to 4 of x sine of pi x over 8 dx. So if we evaluate this part, 8 over pi 4 square sine of pi times 4 over 8 sine of 4 pi over 8 is sine of pi over 2, which is 1. When we substitute the lower limit, everything would be 0 here. So 4 times 8 4 square over pi, that's the value. So Iy is 32 over pi. 4 times 8 is 32 over pi 4 square. Then sine of pi over 2, which is 1. Then minus 4 times 16 over pi is 64 over pi. Integral 0 to 4 of x sine pi x over 8 dx. So you just copy that part. So simplifying this is 32 times 16 over pi. So Iy is 162.975 minus 64 over pi integral of x sine of pi x over 8 dx. So we have another integration by parts here. So I let u2 be x, then du2 is dx. So that means differential v sub 2 is pi x, sine of pi x over 8 dx. So that the integral is 8 over pi, negative 8 over pi cosine of pi x over 8. So Iy is 162.975 quantity minus 64 over pi, then negative 8 negative 8x over pi cosine of pi x over 8, then minus this the integral. So Iy is 162.975 minus 64 over pi, quantity negative 8x over pi, this product here, cosine of pi x over 8 from 0 to 4, then minus this product, so minus of negative 8 over pi, so that's why it's plus 8 over pi here, cosine of pi x over 8 dx. So if we substitute the upper limit, cosine of 4 pi over 8 is cosine of pi over 2, which is 0. So when we substitute the upper limit, it's 0. Lower limit, because there is x here, is also 0. So everything here will be 0. Then minus 64 times 8 over pi times pi. The integral of cosine of pi x over 8 dx is negative 8 over pi sine of pi x over 8. So Iy is 162.975 minus 64 over pi quantity 0 plus 8 over pi times integral of cosine pi x over 8 dx is 8 over pi sine of pi x over 8 from 0 to 4. So since sine of 4 pi over 8 is sine of pi over 2, this is 1. For the upper limit, it is 64 over pi square. When x lower limit 0, sine of 0 is 0, so everything is 0. Therefore, Iy is 162.975 minus 64 times 64, so minus 64 cube, 64 square rather, over pi cube. So Iy is 162.975 minus 64 square over pi cube. And that is 100, that is 30.87 inches to the fourth. So you verify this answer by using your calculator. From here, it's already finished, actually, because the high-tech calculator is allowed. So you check. Level 22, use the differential element shown to determine the moment of inertia of the triangular area about the x and the y-axis. Also determine the polar moment of inertia about point O. So here's the given figure. So let's just follow the instruction there. Use integral calculus, but we'll check this using the already derived formula for moment of inertia of triangular area and rectangular area. So let's call the length, half length from, or distance of this point from the y-axis as x. The thickness is dy, and since the distance is y, differential ix is 2 times, so we multiply it by 2 because we have two symmetrical areas, left and right of the y-axis, and above the x-axis also. So differential ix is 2 times distance square y square, differential area is x dy. And from the figure, y as to x equals h as to b over 2. So that means y is 2h over b times x, or x is by over 2h. So differential ix is 2 times quantity y square x dy, 2 times square of distance, then differential area x dy. Then because the variable of integration is y, defined by the differential, so we replace x by by over 2h. So Ix is 2 integral from 0 to h of y square. X is by over 2h dy. So we have 2b over 2, so it's just b over h. The integral of y cubed dy is y to the fourth over 4. So Ix is b over h y to the fourth over 4 from 0 to h. So that is bh cubed over 4. So Ix is bh cubed over 4. Another way is moment of inertia of this rectangular region is 2 times moment of inertia of rectangle, this rectangle here, minus moment of inertia with respect to the base or with respect to the x-axis, minus the moment of inertia of this triangle with respect to the base or with respect to the x-axis. Moment of inertia of a rectangle is b over 2 h cubed over 3, while the moment of inertia of a triangle with respect to the base or the x-axis is b over 2 h cubed over 12. So Ix is 2 times Ix of rectangle minus 2 times quantity Ix of rectangle, this rectangle here, minus this triangle here with respect to the base or with respect to the x-axis. So Ix is 2 times, base is b over 2, height is h, so h cubed over 3, minus b over 2, h cubed over 12 for that triangle. So Ix is bh cubed over 4. So it checks. Iy, differential Iy is 2 times 1/3 x cubed dy. So differential Iy is 2 times 1/3 of x cubed. We have strip rectangular with respect to the y-axis, dy. And x is by over 2h. So Iy is 2/3 integral from 0 to h of by over 2h cubed times dy. So simplifying this is 2b cubed over 8. So 2 over 8 is 1/4. 1/4 times 1/3 is 1/12. So Iy is 1/12 b cubed over h cubed, or b cubed over 12 h cubed. Then integral of y cubed dy is y to the fourth over 4 from 0 to h. So h to the fourth over 4 cancel, h cubed. So this is b cubed h over 48. So Iy is b cubed h over 48. Then another way of computing Iy, we have two triangles with respect to the y-axis, and the y-axis is like the base here, and it is b cubed h. The base is h, the height is b over 2, so it's like h b over 2 cubed over 12, then times 2. So Iy is 2 times Iy of triangle, and the Iy of triangle is like the moment of inertia of triangle with respect to this y-axis. So if we imagine that h is the base and the height is b over 2 perpendicular to the y-axis, then it is h b over 2 cubed over 12, then times 2. So Iy is 2 times h b over 2 cubed over 12. So if we simplify this, that gives us b cubed h over 48 also. So that's it. Actually, you can also determine Ix and Iy without integrating by just using these already known formulas for moment of inertia of triangle or rectangle. Also determine the polar moment of inertia about point O. The polar moment of inertia about point O is Ix plus Iy, since we already evaluated Ix and Iy. So IO is Iz equals Jo equals Ix plus Iy. So IO equals IZ equals JO equals B H cube over 4 plus B cube H over 48. Factoring out B H over 48, then we have B square plus 48 over 4 is 12 H square. So IO equals IZ equals DO equals BH over 48 times quantity B square plus 12H square. So that's it.